it for the benefit of those who weren't there. Okay? So you would have some of the notes. I'm just doing it for the others. Okay? And then we will continue with some graphical work today, both on straight line and curves. All right, so take these notes. This is the close of what were doing the last time.
You gave me last time too to write.
Yeah, you all got it ready. No, you don't have to write. Take it. Okay, so the first note is, if two lines are parallel, their gradients are equal. So that's the first note. First note, if two lines are parallel, their gradients are equal. Second note, if two lines are perpendicular, the product of their gradients, if two lines are perpendicular, the product of their gradients is minus 1. Is minus 1. Or if one line's gradient is m, the other line's gradient is minus 1 over m. Is minus 1 over m. Third note, note 3. Note 3. For a line joining 2 points, point A, which will be given by x1, y1, and B, that is point B, which is given by x2, y2, A. The length of the line is A. The length of the line is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so if we want to find the length of the line that joins point A to point B, the coordinates of A being x1, y1, the coordinates of B being x2, y2, then that length AB would be given by this equation. Okay, so this is what you would need to memorize. B, so the B part of note 3 is, the midpoint M with coordinates x bar, y bar. The dash at the top is said in maths to be bar, so x bar, comma, y bar, where x bar and y bar, of course, represent the average of the x and the y coordinates but I'll go ahead and explain here. The midpoint M, which is x bar, y bar, is equal to M. And in order to calculate what x bar is, what we would do is we would add x1 plus x2 together and divide that answer by 2. And that would give us what the x coordinate or x bar is for the midpoint. And to get the y coordinate of the midpoint or y bar, we do the same thing with the y coordinates. We find the average of them, which is y1 plus y2 over 2. Right, that is note 3, part B, and then note 4. Note 4. Note 4 says, the perpendicular bisector of a line, passes through the line's midpoint. The perpendicular bisector of a line passes through the line's midpoint and adheres to note 2. The perpendicular bisector of a line passes through the line's midpoint and adheres, A-D-H-E-R-E-S, and adheres to note 2 above. And adheres to note 2 above. Okay? Your next note below that will be, and this will be for everybody now. Everybody. The heading will be sketching of lines of the form. Sketching of lines of the form y equal to mx plus c. Sketching of lines of the form y equal to mx plus c. The title is Sketching of Lines of the Form y equal to mx plus c. Okay, so the first sketch we'll draw, first one we'll draw up here, will be of the form y equal to kx, k being any number. So for example, y equal to 2x or y equal to 10x. Right? That's the most simple format. Okay, so how that would look if you're drawing it is a simple drawing like this. Okay, so that's how it will look, where it would pass through 0, 0. All right, and the gradient would be 2. This is how it will look. So the gradient of this will be 2. So if we were to measure the rise and divided by the run, you will get a figure of 2. It will always pass through 0, 0. This, of course, here would be the y-axis, and here will be the x-axis. Okay, so that's the first type. Second one, this will be of the form y equal to minus kx, right? Y equal to minus kx, or y equal to minus 2x, for example, right? Or y equal to minus 10x, for example. Okay, so if we were looking at one where the gradient was negative, then what we would do is realize that the graph would go in this direction now. Okay, so instead of sloping as shown in the first diagram, it would should be sloping as shown in the second diagram. Right? Again, it would pass through the origin like that, 0, 0. So without actually plotting anything, once we learn this, you will actually know what the shape of the graph is supposed to look like without plotting any values. Okay? The third one, we'll be looking at y equal to 2kx plus c. Y equal to kx plus c, for example. An example of that might be y equal to 2x plus 3, or y equal to 2x minus 2. So we'll put that up on our drawing here. Okay, so in this diagram, we're looking at two lines which are parallel, y equal to 2x plus 3. The gradient of this line is 2. And it will cut the y-axis at this point here, which is positive 3. So we see if we look at this graph, y equal to 2x plus 3, it's cutting the y-axis here at positive 3, and that will be the y-intercept. This line, y equal to 2x minus 2, it also has a gradient of 2, as evidenced by the number in front of x, when it's put in the form y equal to mx plus c. And therefore, it will be parallel to the first line on top. But what is important to note is that it's going to cut the y-axis at a different point. It's going to cut it at where y is equal to this number here, which is minus 2. So we see that cutting going on here, and that will be the y-intercept for this particular line. It will be here. So the y-intercept coordinates will be 0, minus 2. And the y-intercept coordinates for the first line, which is y equal to 2x plus 3, will be 0, 3. Okay? So from the structure of the line itself, you Here, write these two closing notes. The first one is to deduce the y-intercept, place x as 0, in the equation for the straight line. To deduce the y-intercept, place x as 0 in the equation of the straight line and solve for y. That's note 1 and note 2. To deduce the x-intercept, okay, and to deduce, this is the next note, to deduce the x-intercept, place y as 0. To deduce the x-intercept, place y as 0 in the equation of the straight line. And solve for x. An example in relation to those last two notes is this. Example, sketch the graph of y equal to 3x minus 2. Sketch the graph of y equal to 3x minus 2. Now, in order to sketch a graph of a straight line, all you need is 2 points. And the easiest 2 points to find is the intercepts. And I just told you how to find the intercepts, right? So what we'll do, we'll just simply find those 2 intercepts and draw a line through those 2, and that's your sketchy line. Okay? So what we'll do is we'll find the x-intercept first. So to find the x-intercept, place y equal to 0. Right? So if this is the equation of the line y equal to 3x minus 2, to find the x-intercept, all we'll do is place y equal to 0 in this equation. So that would imply that 0 will be equal to 3x minus 2, which implies that positive 2 will be equal to 3x, which implies that 2 over 3 will be equal to x. 2/3 will be equal to x. And this here will be the x-intercept. Okay? So you could write, therefore, x-intercept is and you write down what the x-intercept will be. The x-intercept will be 2/3, which we just calculated for the x value, 0 for the y value, because we know we place y as 0 whenever we're trying to find the x-intercept. So y is 0, and this that we found was the x-intercept value. When we draw this curve, you'll see exactly where those points lie. It's very easy. And then the next step to get the other point that we'll be using to sketch the curve is we'll find the y-intercept now. So you write, to find the y-intercept, what we do, we place x equal to 0, right, in the equation of the straight line, which means that y equal to 3x minus 2 becomes y equal to 3 by 0 minus 2. Because we place x as 0 in the equation of the straight line. So this becomes y equal to minus 2. And we expected that because we know that the y-intercept is always this value here in any case. We just worked it out. Okay? So y equal to minus 2. Therefore, y-intercept is, what the y-intercept will be? Well, we know in the y-intercept we place x as 0, which is this. And we worked out the y-intercept as y equal to minus 2. So the y-intercept will be minus 2, and the x value here is 0. So these are the things that we will need to sketch our curve quickly. Just those 2 points we can do it with. So very quickly, we could just draw this curve so you could see this line so you can see what it is. If this is the y-axis here, and this is the x-axis here, and let's say we said from here to here was 1, 2, and so on. And on this side we said this was minus 1, minus 2, and so on. Then let us get first of all the x-intercept. The x-intercept was 2/3 0. So 2/3, if we break this up into 3 parts, that'll be, let's say 1, 2, 3. This point here will be 2/3, right here. So that is where our x-intercept will be. Our x-intercept is located at 2/3 0, which means the line is going to cut the x-axis at where x equal to 2/3. So it's going to cut it right here. And also now, the y-intercept is where the line is going to cut the y-axis, and that's where y is equal to minus 2. So that will be at this point here. Very easy to sketch a curve or to draw the line, sorry, by simply connecting these 2 points, like that. So that would represent the line y equal to 3x minus 2. And all we did was obtain the 2 intercepts, the x-intercept and the y-intercept. And to get each one, we first of all place y equal to 0 to get the x-intercept and solve. And then we place to get the x-intercept, sorry, to get the y-intercept, we place x as 0 and we solve. Having gotten that, we were able to sketch our straight line. Okay, so your next heading will be sketching and interpreting. Your next heading will be sketching and interpreting quadratic curves. Sketching and interpreting quadratic curves of the type ax squared plus bx plus c. Sketching and interpreting quadratic curves of the type ax squared plus bx plus c. Okay, so the first note is to determine if the function in brackets curve to determine if the function in brackets curve has a maximum or minimum point, has a maximum or minimum point, look at the sign, S-I-G-N, of A. Look at the sign of A. That is, if A is negative, that is, if A is negative, there is a maximum point. That is, if A is negative, there is a maximum point. And if it is positive, there is a minimum point. So let's say, for example, we had an equation or a function f of x, which is the same thing as saying y, equal to x squared minus 2x minus 3. This would give us a curve. All quadratic functions give us a curve. But the first thing we have to determine, if we have to sketch them, is whether you're going to have a maximum or a minimum point. Now we said that if A is negative, you have a maximum point, and if A is positive, you have a minimum point. That's the note you just took. So, but we have to be able to identify what A is before we could even find out what the sign of A is. So in the first one, which is y equal to f of x, which is equal to x squared minus 2x minus 3, A in this case would be what? A is equal to 1. A is a coefficient of x squared. It's a number in front of x squared, and in this case the coefficient of x squared is 1. It's understood to be 1, right? That's a reminder. In this case here, y equal to minus 2x squared minus 6x plus 2, A is equal to what? A is equal to minus 2. A is a number in front of x squared. So in the first instance, A is 1, and therefore the sign of A is a positive sign. A is positive, and therefore we expect to have a minimum value, right? So since A is positive, right, the curve of this particular function has a minimum value. Okay? So without drawing anything at all, you know what it has up front. So this curve is going to look like this, right? It's gonna have a bottom point, a minimum point. Minimum point is going to exist. Okay? In this case here, right, y equal to minus 2x squared plus 6x plus 2, that is not going to be the case, because A in this case is negative. And if A is negative, we learned in that first note that the curve will have a maximum point. Okay, it will have a maximum point, which means that it's not going to look like this. It's actually going to look like the reverse. So if we had to get some idea of how it would look, right, it would look something like that, because it now has a maximum point. Okay? So that's how we identify upfront if it has a maximum or a minimum point. So we take a little note there on that. Okay, so as a continuation of this point here, you write, to find the minimum or maximum value, to find the minimum or maximum value of the function, to find the minimum or maximum value of the function, we complete the square. We complete the square. i.e., to find the minimum or maximum value of the function, we complete the square. i.e., we express ax squared plus bx plus c, i.e., we express ax squared plus bx plus c in the form a into open brackets x plus h all squared plus k. A open brackets x plus h squared plus k, where h is equal to b over 2a, where h is equal to b over 2a, and k is equal to 4ac minus b squared all over 4a. Okay, this is what we had studied before, and we just studied the mechanics of it. Now, this is when we were studying quadratic equations. We studied how to complete the square and how to use it to solve the quadratic equation and to solve the quadratic equation and to factorize it. All right. Here we will be using it to help us to sketch curves, because when we need to find the maximum and minimum values, the first thing is to express the quadratic function in this format, which is we complete the square. So you continue writing, k is the minimum or maximum value of the function. K is the minimum or maximum value of the function. K is the minimum or maximum value of the function. And minus h and minus h and minus h is the value of x, and minus h is the value of x is the value of x at which this maximum or minimum occurs. Is the value of x at which this maximum or minimum occurs. Okay, so what is this about? What we're saying is, if for example, you had a function like we had just spoken about there. Let's say we had this function y equal to, and it's the same thing as saying f of x equal to x squared minus 2x minus 3. Let's say that's the function that we had. And they said to sketch this curve. Well, the first thing we will be able to say is that because a is 1 and 1 is positive, we know it has a minimum point. It doesn't have a maximum point, it has a minimum point. So we know it's going to be curving downwards with a minimum point. But where's that minimum point? What's the value of the minimum point if you want to sketch it? Right? You could find the value of that minimum point by expressing it in this format. Good? When you express it in this format, where h is b over 2a and k is 4ac minus b squared over 4a, then you will know where the maximum point is and you'll know the value of x at which it occurs. So for example, let's say we knew that the curve was shaped like this, then the minimum point, let's say, would be somewhere right here, right at this position here, where the curve is right to the bottom there. That's the minimum point. But what is the value of that? The value of that will be, if you were to come straight across onto this axis here, that will be the value of that point, the value on the y-axis. And we could get that by working out what k is, which is by working out this equation here. Okay? And if we were to go through that process, we would work out that that would work out to be minus 4. Okay? And the next thing is, if this is the minimum value of the function, what is the value of x at which that minimum occurs? That's the next question, in order to be able to sketch it. And the value of x at which it occurs could be obtained by going up to this point here on the x-axis. Let's say this is the x-axis here, and this here is the y-axis. Then the value of x at which it occurs will be right here. And how could we get that value? Well, from the completed square equation, we could work out what h was, b over 2a, whatever h was, then minus h is the value of x at which that maximum occurs. So if we worked out h from this equation, all we had to do was find minus h, which is multiplied by minus 1, and that would give us this value here. And in this case, that value here would work out to be 1. So the minimum point in this particular function would be given by minus 4 would be the minimum value, and the value of x at which it occurred will be 1. So the minimum point will be 1 minus 4. Okay? Meaning, starting here, you go 1 across and minus 4 down, and that will be the minimum point. Okay, so in that way, you would be able to sketch that curve to that point. So take the relevant notes to have that note in your textbook, in your notebook, sorry. Okay. This here will be okay, so in continuing to do the sketches, there are some other points. This was the major point. So let's take the other points. So point, all that would be point 1. Point 2 now. The y-intercept, open brackets, point where the curve cuts the y-axis. The y-intercept, open brackets, the point where the curve cuts the y-axis, close brackets, is given by is given by 0, C. Is given by 0, C. Where C is the value given in the quadratic expression. Where C is the value given in the quadratic expression. What quadratic expression are we talking about? Remember the quadratic expression where y is equal to ax squared plus bx plus c? Remember that? That's the c they're talking about. So to find the y-intercept, all we have to do is take note of this value here, right? And that will give us our y-intercept. The y-intercept, x value is always 0, and c is the c that comes from here, which in this case is minus 3. The example we have on the board there. So this curve is going to cut the y-axis at the point 0, c, which in this case will be 0, minus 3, in this our particular example. And that means that this point here, which is the y-intercept, which is where the curve is cutting the y-axis, will be the point on the y-axis where y is equal to minus 3. So here will be minus 3, like that. Okay? So put that in. Okay, so that was node 2, node 3 now. We're looking at the x-intercept now. So the x-intercept, you write in. The x-intercept, that's node 3. Open brackets. The points where the curve cuts the x-axis. The x-intercept, open bracket. The point or points where the curve cuts the x-axis. Close brackets. Are obtained when we let the quadratic be equal to 0. When we let the quadratic be equal to 0 and solve for the values, when we let the quadratic be equal to 0 and solve for the values of x that make it so. And solve for the values of x that make it so. Full stop. These values of x or for x are called the roots of the equation. These values of x or for x are called the roots of the equation. So to get the x-intercept, we said that we put the equation equal to 0 and solve. In other words, in our particular example here, we would put x squared minus 2x minus 3 equal to 0 and solve it. Now we know 3 ways to solve that, don't we? The method of factors, quadratic equation, and completing the square. But if we already went through completing the square to get the minimum point or the maximum point, then it might make sense just continuing to solve it to get the values of x from this equation here. Having gotten the values of x, those would be the values of x that the intercepts would take place at, which would be, one will be here and one will be right there. Those are the intercepts, the x-intercepts, where the curve is cutting the x-axis. So all this is involved in sketching the curve. So if we were to go about solving this, any one of the 3 ways, we would get the following solutions. We'd get one solution as x equal to minus 1 when we do the solution, or we get x equal to 3. So it means that this value here is minus 1 and this one here would be 3 when we do that solution. Okay, so you could just put that in. Those values that we just got for x equal to minus 1 or x equal to 3, they are also known as the roots of the equation. So if in the question they said, what are the roots of the equation? You would say the roots of the equation are x equal to minus 1 or x equal to 3. They are also the intercepts on the x-axis. Okay, the fourth and final note in this area, would be made up of 3 smaller notes. The first one is the domain of the function. The domain of the function represents the that x can take. The domain of the function represents the values that x can take. Second, the domain of the function represents the values that x can take. Next note, under note 4, the range of the function, represents the values that y can take. The range of the function represents the values that y can take. And the third part of note 4 is, these can both be read directly off of the curve. These can both be read directly off of the curve. Okay, so in this case here, in our example here, what we are saying is, if they ask us to find the domain of this function represents the values that x could take. Now the values that x could take will be wherever the graph, let's say the graph stopped here and here. That's how far it extended. The domain would be what is the x value that relates or pertains to that end point there, because the graph stops there. It would be this value here. What about the next side? It would be wherever this comes down to on the x-axis, which would be right there. So the domain would be between this value on the left and that value there on the right. In actuality, that ended up being minus 2 and 4. So if we were to actually draw this value here would be minus 2, and this one on this side here will be 4. Okay, if we were to actually draw it out, this is what we would have obtained. So you could just take a note of that. Okay, so the domain would be x between -2 and 4, including -2 and including 4. Okay, that would be the domain. And the range now is the values that y could take. So whatever is the topmost value here, to whatever is the bottommost value of y would be the range, right? In this drawing, the bottommost value of y would be the minimum point, which would be -4, and the topmost value would be whichever one of these two is higher you come across onto the axis, right? And in this case, the topmost value was 5, and the bottommost value was -4. So in other words, if we came across here, right, both of these happen to be at the same level, this here would be 5, that's the highest point on the y-axis, and the lowest point on the y-axis would be this one here, -4, right, which actually turned out to be the minimum point. So the range would be y between 5 and -4. That's what is known as the range. Okay, so we could just write it in here. The range would be y lying in between -4 and 5. Okay, so you take a note of that. So you see, in order to sketch a curve, right, of this type, there are several things you need to be aware of, which we went through in detail. So let us now look at an example from a past paper and go through it together. So you write down this example. It's taken from May, June 2005. Question 9. May, June 2005, question 9. Okay. The first one we're looking at is question 9a. So you could write it 9a. And it says, write 5x squared plus 2x minus 7. Write 5x squared plus 2x minus 7 in the form a, open brackets, x plus h, close brackets, all squared, plus k. Where a, h, and k are real numbers. Okay, so that first part in May, June 2005 required you to take a quadratic which is in the form a x squared plus bx plus c and complete the square. That is, put it in the form a into x plus h squared plus k. Now, they were nice to you here because they didn't just tell you complete the square. If they just told you complete the square, you would have to know that complete the square means put it in that form. But they were nice to you. They said, put it in this form. Right? If, however, they are not nice to you when you go to sit it and they tell you complete the square, then you know what it means. Right? It means to do it that way, put it into that form. So if we are required in 9a to put it into that particular format, what we have to remember is that h will be equal to b over 2a, that's 1. And we also have to remember that k is equal to 4ac minus b squared all over 4a. They're not going to give you that in the solution sheet. At the front, you know, they give you a solution sheet. They're not going to give you that. You have to memorize this and walk with that into the exam. If it is that you know your memory not so good like mine's, then the night before you'll go over all of the formulae that you know you forget easily. And when you write into the exam, when you walk into the exam and they say, listen, start, you write down all those formulas that you just looked at in your sheet that you know you'll forget. So you just have a short window between when you last saw it and when you have to use it again. Okay? If you know that those things are going to come up, that's the way that you handle it. So now all we have to do is work it out. What is H? H will be equal to B over 2A. In this equation here, in this formula, B is 2. This 2 is written below, and the A will be 5. So it means that H will work out to be 2 over 2 by 5, 10. 2 over 10, which is the same thing as 1 over 5. So we know what H is right away. And we can also work out what K is. Okay, so if we stick all of the numbers into K, we get 4 by 5 by minus 7 minus 2 squared all over 4 multiplied by 5. Alright, and if we go through the process and you work out what that is, you will get minus 144 over 20, which works out to be minus 7 and 1/5. Okay? When you work out that, you'll get minus 7 and 1/5 for K. So therefore, if we have to put it in that form, we can now write it. Therefore, the required form is and you can put what the required form is, because the required form is A into X plus 8 squared plus K. So A in this case is 5, so you'll put 5, open brackets, X plus H. What is H? H is 1/5. So it'll be plus 1/5 all squared plus K. Now plus K is plus minus 7 and 1/5. The plus has no effect on the minus sign when you remove the brackets. So it will be minus 7 and 1/5. Okay, so the required form is 5 into open brackets x plus a fifth all close brackets all squared minus 7 and 1/5. So that will be the answer for 9A. Okay, so 9B now, in that same exam, we are looking at what 9B asks us to do. Okay, in that exam, 9B said, hence or otherwise, we're writing it, hence or otherwise. In that exam, they said 9B, and 9B said, hence or otherwise, determine 1. Determine 1. The first thing they want us to determine was the minimum value of the function. So part 1 said, hence or otherwise determine the minimum value of the function y equal to 5x squared plus 2x minus 7. Y equal to 5x squared plus 2x minus 7. So that was part 1 of 9b. Part 2 was, hence or otherwise determine, part 2, the value of x at which the minimum occurs. Part 1 was the minimum value of the function. Part 2 was the value of x at which the minimum occurs. Okay, we have to determine the minimum value of the function. And we know from our notes that the minimum value of this function up front, before we do anything, is given by the value of k. Right? Our notes taught us that. And we're going into this exam with all of that information already. So we know that the answer for the minimum value of this function is going to be this answer here. Minus 7 and 1/5. Right? But it is not prudent to simply write down that number. You have to give some sort of a working. Okay? And the working goes like this. You write the minimum value of the function, right? Occurs when and the minimum or maximum value of the function always occurs when this part here in brackets is equal to 0. So that's what we will write. The minimum value of the function occurs when x plus 1 over 5, that part there is equal to 0. It always happens when that is the case, right? Which implies that 5 by 0 squared minus 7 and 1/5 will be equal to y. Because remember, we're saying x plus a fifth is equal to 0. This part is 0. And if you work that out, then you get y is equal to minus 7 and 1/5. Okay, and therefore the minimum value is y equal to minus 7 and 1/5. Okay, so we go in there knowing that the minimum or maximum value is the value k, but the statement is this format. Okay, so you have to learn that statement, and that will be for part 1. In part 2, they wanted to know the value of x at which the minimum occurs. The value of x at which the minimum occurs will also be found by this relationship. But we know the answer up front. The value of x at which it occurs is always minus h. Remember we just studied that? So we know up front that the answer is minus 1/5. Right? But what's the statement? The statement is similar. So I'll give you the statement here. The value of x at which it occurs is given by same thing, x plus a fifth equal to 0. Right? So both the minimum value of the function and the value of x at which it occurs is given when the part in brackets is equal to 0. Now if x plus a fifth equal to 0, then that implies that x will be equal to minus 1/5, which we expect it to be in any case, because we learned that up front. And therefore, this is the answer for part 2. Okay, and what did 9c ask us? 9c said, you write in, hence find the values of x. 9c said, hence find the values of x for which, hence find the values of x for which 5x squared plus 2x minus 7 is equal to 0. 9 part C said 9 part C said, hence find the values of x for which 5x squared plus 2x minus 7 is equal to 0. Okay, so in order to answer that question, we had to recall that the format of 5x squared plus 2x minus 7, when expressed in the completed square format, was given by 5 open brackets x plus a fifth all squared, close brackets all squared, minus 7 and 1/5. This is the format when you express it in the completed square form. And they said to you, hence find the values of x for which 5x squared plus 2x minus 7 equal to 0. The hence tells you you have to use what you got up front to help you solve it. So if you went in this question and used method of factors to solve it, or you use the quadratic formula to solve it, you would not get any marks. Nothing. Even though it was correct. Because you didn't answer the question that they asked you. The question said hence solve. So it means that you have to use this equation here or that relationship to solve it. Okay? So how do we go about doing it? We did something like this already. We said if this is equal to 0, if 5x squared plus 2x minus 7 equal to 0, what it means therefore is that this here, which is the 5 open brackets x plus 1/5 squared minus 7 and 1/5, we know that then that it must be equal to 0. Because remember, they are one and the same, just expressed differently. So how do we solve this, right? Well, the way that we did it in the last session that we looked at this was we said 5 into open bracket x plus a fifth squared would therefore be equal to 7 and 1/5. How did we do that? We add 7 and 1/5 on this side and we add it on this side. The next thing we'll do is divide on both sides by 5. So it means if I divide on the left hand side by 5, I'll have x plus a fifth all squared remaining, and therefore I'll have to divide on the right hand side by 5 as well, which is this. And if I do that on my calculator, I'll get this figure, 111 over 25, right? So you guys could go home and check that. Once you have that now, the next step is how do you get rid of the squared sign on top there? How do you do that? What's the opposite of squaring? Square rooting, right? So to get rid of this squared sign, I have to square root on the left hand side. So if I take square root on the left hand side, I'll get x plus 1/5 because I'll remove the squared sign by doing square root here. And if I do square root on the left hand side, I also have to do square root on the right hand side. So it becomes this. Okay? And the square root of 111 over 25, when you work it out on your calculator, you will see this value here. But if you don't take heed of what I'm going to say next, you're going to lose half of the marks. And what I'm going to say next is the square root of any number is plus or minus. So it means that this must be plus or minus. And if you don't remember that, you're not going to put it in the exam. You're just going to stick it in your calculator, get 1 and 1/5 and go ahead as normal. You'll be losing marks, giving them marks for no reason. Okay? So then what is the next step after that? Well, we want to get x by itself. So to get x by itself, we have to do the opposite of adding 1/5, which means we have to minus 1/5 on the left hand side. If I minus 1/5 there, I also have to minus it on that side. So what happens is plus or minus 1 and 1/5 remains on the right hand side here, and I have to minus 1/5 here as well. Because I did it here, I have to do it here. Okay? So what I'm going to end up with is two possible values for x. One value of x will occur when I take the positive 1 and 1/5 and I minus a fifth from it. And the other value of x I will get, the other value of x I will get is when I take the minus 1 and 1/5, because remember it could be plus or minus. When I take the minus 1 and 1/5 and minus 1/5 from it, I will get the other possible value of x. So from the first calculation, I'll get x equal to 1 and 1/5 minus 1/5 is 1. Or, in this case, minus 1 and 1/5 minus 1/5 will be equal to minus 1 and 2/5. Right? Again, if you're not too sure about it, you have your calculator, just stick it in and you should get that. So these are the two possible values of x that they're looking for based on that relationship. Okay, so make sure you have that. Okay, the next part was 9D. So you're writing down what 9D was, which was the last part of that question in the exam. Okay, and 9D said, sketch the graph. 9D said, sketch the graph of y equal to 5x squared plus 2x minus 7, which is exactly what we have been dealing with all the time. Sketch the graph of y equal to 5x squared plus 2x minus 7, showing 1, the coordinates of the minimum point. Showing 1, the coordinates of the minimum point. 2, the value of the y-intercept. 2, the value of the y-intercept. And 3, the points where the graph cuts the x-axis. And 3, the points where the graph cuts the x-axis. Okay, so in order to answer 9D, what we'd have to do is to bring to our forefront, or the forefront of our minds, all that we had done before. What we did before, in 9A, we expressed it in a particular form, which is the completed square form. In 9B, we found what the value of y minimum was, which was the minimum value of the function. We found the value of x that made it so, which is the value of the minimum value of x, right? Or the value of x at which the function is minimum. That was x equal to minus 1/5. And then they asked us to solve this equation, and we solved it, and we got what x, the values of x were when that occurred. Now, what is interesting is that if you check back the notes that we gave to you, these values here for x are really known as the roots of the equation. And the roots of the equation are really the x-intercepts, if you check back your notes. So these here are the x-intercepts. And this is what is going to help us to do our sketching. So let us quickly do our sketching. First of all, we look at the x-intercepts, even though it's 9C. It says x equal to 1 and x equal to minus 1 and 2/5. It means then that this curve is going to cut through x equal to 1 there and x equal to minus 1 and 2/5. So if this is minus 1 and we were to break this up into 5 parts, right, just averaging there, minus 1 and 2/5 would be minus 1 and 1/5, minus 1 and 2/5. So this area here will be minus 1 and 2/5. So we know that these are the roots of the equation and the curve is going to cut the x-axis there. We also know that because a is 5, right, when we looked at this it was 5x squared plus 2x minus 7, a is 5, it means that since a is positive, you're going to have a minimum point. So this has a minimum point, and we also know the value of what the minimum point is. The minimum point is where x is equal to minus 1/5. So if we say minus 1/5 is somewhere around here, we know the minimum point is going to lie somewhere along x equal to minus 1/5, but also where y minimum is minus 7 and 1/5. Where's minus 7 and 1/5? This is minus 6, minus 7, let's say is here. Let's say here is minus 8. Minus 7 and 1/5 will be somewhere around here. So we write minus 7 and 1/5. So you know what? The minimum point is going to be, if we extrapolate this out and we bring this down here, this is where the minimum point is going to be, where x is equal to minus 1/5 and the y value, which is the minimum value of the function, is minus 7 and 1/5. That's this point here. Okay? So we could actually do some drawing. The other thing is that, where is the y-intercept going to be? The y-intercept is always given by this value here. It's always given by the c value in y equal to ax squared plus bx plus c. So we know this is where it's going to cut the y-axis at minus 7. So it's going to cut it right here. So our curve must go through minus 1 and 2/5 because it's going to cut the x-axis there. It must go to a minimum value here, where x is minus 1/5 and y is equal to minus 7 and 1/5. And then it must curve up there now and cut back the y-axis at minus 7, and then come back up on the next side and go through where x is equal to 1. Okay? Because we know these are where it cuts the axis. This is the minimum point here, where x is minus 1/5 and y is minus 7 and 1/5. It's going to cut the y-axis at this value here, and it's going to come back and cut the x-axis on that side. So this is how your curve is going to look in a sketch. You could draw it neater than that, okay? But this is just a very rough sketch of what it would look like. Okay, and have we answered the question they asked? They asked for the coordinates of the minimum point. Yes, we have the coordinates of the minimum point. We could actually put it in a little better for them, where we could put minus 1/5 here, and we could put minus 7 and 1/5 next to it. So that would be the coordinates of the minimum point. Okay? The value of the y-intercept, yes, the value of the y-intercept is given to them here. Right, that's minus 7. And then the points where the graph cuts the x-axis, that was also given to them here. So we answered all the questions that they had asked us in that question. Okay, so the homework is the diagram below shows the graph of the function. The diagram below shows the graph of the function f of x equal to x squared minus 2x minus 3 x squared minus 2x minus 3 for, I'm writing it on the board here, for x between a and b, including a and including b, like what we have on the board there. So the diagram below shows the graph of the function f of x equal to x squared minus 2x minus 3 for x between a and b. The tangent to the graph at 2 minus 3 the tangent to the graph at 2 minus 3 is also drawn. Use the graph to determine use the graph to determine A. Use the graph to determine A. Values of A and B. Values of A and B which define the domain of the graph. Values of A and B which define the domain of the graph. B. Values of X for which x squared minus 2x minus 3 is equal to 0. X squared minus 2x minus 3 is equal to 0. That's B. C. Coordinates of the minimum point on the graph. Coordinates of the minimum point on the graph. C. Coordinates of the minimum point on the graph. D. Whole number values. D. Whole number values of X for which x squared minus 2x minus 3 is less than 1. Right, written up on the board there. For which x squared minus 2x minus 3 is less than 1. That's part D. And part E, the gradient of f of x, equal to x squared minus 2x minus 3. The gradient of f of x equal to x squared minus 2x minus 3 at x equal to 2. At x equal to 2. You have to draw this so you'll know what to do. Four, one. 3 and then 4, 5. Okay, the one with the tangent, don't worry about that one. The number E, don't worry about that one because it's difficult to put it in. Right? You can do the other parts. Thank you very much.